Hi students, welcome to Ankush Sir classes. Today's topic is types or categories of instructions in 8085 microprocessor. Now first of all, what is instruction? The instruction is a set of binary pattern designed inside a microprocessor to perform a specific function. Now in microprocessor, the entire group of instructions is called instruction set. So instruction set determines what functions the microprocessor can perform. And these instructions can be classified into 5 functional categories. So, a 8085 microprocessor, inside of the 8085 microprocessor, all the instructions are categorized into 5 functional categories. Means, depends on its functions, a specific instruction is categorized to particular group. So here, just I explained that 5 total categories are there. So first category is a data transfer group of instruction. Second category is arithmetic group of instructions. The third category is belongs to logical group of instructions. The fourth is branching group of instructions. And the last one is a stack group of instructions. So these are the total 5 groups in 8085 of instructions. Means in 8085 whatever the all instructions are there that are divided into these 5 groups. So from next slide we will learn each group instructions. So the first group is data transfer group of instruction. Now here the name itself suggests that this group of instructions are used to transfer a data from one place to another place. Now here a one place to another place means it transfer a data between the registers or between the memory locations and registers. In 8085 microprocessor, actual transfer of data means it is a copy of data from one place to another place. So once again, a data transfer group of instructions are used to move, here we can say that a copy of data between registers or between memory locations and registers. So data can be transferred between two registers, between the register and memory locations, memory location to registers. So here they are given the examples, move a comma b, that is moving copy a register B data to register A data. So here they are given the instruction move A comma B. So I already explained that a destination come first. So here move A comma B means a data is moved from B register to A register. So here it is a source and it is a destination. So B is a source register and A is a destination register. So this instruction MOV means move is a data transfer group of instruction which is transfer a data between two registers. Now the next instruction MVIC05H, it is also a data transfer group of instructions. The meaning of MVI means move immediate a 05 data to register C. Means here we can directly put a data 05 into registers So instead of C, I can write here B also. You can write any register of 8085 microprocessor. So this is also transferring the data directly to the register. So next is move B comma M. So this move B comma M is also a data transfer group of instruction which transfer a data between memory and register. In the above example, it transfer, it moves a data between two registers, but here it transfer data between register and memory. So the meaning of this instruction is move the data of memory to the register B. Now the next instruction is MVIM05. So here also this instruction is same as this. Instead of using register, I am using the memory. So I can transfer data directly to the memory which is pointed by HL pair. So move M comma B STA 7000. So this is STA 7000H is an instruction which is used especially whenever the result we want to save into particular location. So here STA 7000H means store accumulator to a given memory location, that is here they are given a 7000 location. So whatever in the accumulator that contains are saved into the 7000 location. So it is also a transferring, a moving a register data, yeah, we can say that accumulator data to a given memory location. So this is also belongs to data transfer group of instruction. LDA, which is opposite to STA. Here in LDA we are not moving a data, we are just a data which is located at memory location is copied to accumulator. So here at location 7000 whatever data is there, that data will be loaded to the accumulator. So here also a data is copied from the memory location to the accumulator. So it is also a data transfer group of instruction. Now the second is an arithmetic group of instruction. Now in arithmetic group of instruction, it performs a arithmetic operation. So these instructions basically performs addition, subtraction, increment, decrement, etc. onto the data. So this increment, decrement, addition, subtraction is done onto data which is stored in register or memory. So in this example they are given some examples: add B, add M, ADI05. Now what is the meaning of this? So here they are given examples: add B. Add B means you just add the register B with the accumulator. So whatever the content of accumulator and whatever content of B is added, and the result will again place back to the accumulator. This is also ADD add M means the content of memory location which is pointed by HL pair is added with the accumulator. ADI05H is also an arithmetic group of instruction which is used to add a 05 content directly with the accumulator. So here with this help of, with this instruction I can add a data directly with the accumulator. So it is a add immediate 05 data with the accumulator. Now here subtract C they are given like a addition, subtraction group of instruction is also used. Like a subtraction, like a addition, subtraction also used. So subtract C means a content of register C is subtracted from the accumulator and the result again placed back to the accumulator. So just remember, subtract C means the content of C are subtracted from accumulator, not vice versa. The next is SUI03H means subtract immediate 03 data from the accumulator. SBBD is the next example they are given, that is subtract register D from accumulator by considering the borrow. So here SBB means subtract D with a borrow. INRC means increment register C by 1 byte. So if the C contains a 08, then increment C will make C as a 9. Decrement M, decrement memory content which is pointed by HLFR by 1 byte. And that D means add the D E pair, uh, add the D pair with the HL pair. So that is also a arithmetic group of instructions. So this arithmetic group of instructions is nothing but using to add, subtract, increment or decrement operations in 8085 microprocessor. Next is a logical group of instructions. The third one is a logical group of instructions. Now basically a logically group of instructions in 8085 performs the logical operations. Now logical operations mean such as a logical AND, logical OR, logical XOR that is exclusive OR, complement, this type of etc. This type of instructions are belongs to logical group of instructions. So this logical AND, logical OR, logical exclusive OR, a complement, all operations are basically done with the accumulator only. So here they are given some examples ANAB, ANAM. Now meaning of this is you just make the logical ANDing of register B with the accumulator. Logical ANDing of memory content which is pointed by HL pair with the accumulator, and again the result will place back to the accumulator. ANI05H means logical, it is a logical ANDing only, but AND immediate 05 data with accumulator. XRA exclusive OR register C with the accumulator. Or ORAB is same as a logical OR gate, that is logical OR is applied between the register B and the accumulator. Compare B, yeah, CMP B means compare B with the accumulator. Now compare B means the content of register B is compared with the accumulator. Now comparison means actual subtractions, and according to that result flags are set. RRC, RLC, RAR. So these instructions are RRC means rotate right content of accumulator by 1 bit. So whenever we want to make the bit-wise operation, this RRC, RLC, RAR, RAL is used. So RRC is nothing but rotate right content of 1 bit of accumulator. So the 1 bit contents are rotated by 1 bit. RLC means rotate uh, content of accumulator by left, yeah, towards left by 1 bit, not 1 byte. RAR is same, but the contents are rotated right by 1 bit, but through the carry. So these are the all logical group of instructions. Likewise here the CMA, that is complement accumulator. Now this instruction is used basically to convert the accumulator data. For example, suppose accumulator has all zeros. So by applying CMA, it becomes all ones. So CMA is nothing but a complement accumulator instruction which is used to complement the data of accumulator. So whatever the zeros are there in accumulator will convert it to 1, and if the ones are there in accumulator, it is converted into 0. So this is a logical group of instructions. Next is branching group of instructions they are given. So in branching group of instruction, basically these instructions allow programmer to change the sequence of execution of program either conditionally or unconditionally. Means to change the sequence of program. For example, if I want to jump to the particular location depends on some situation. For example, JNC, that is jump on no carry, JMP address, so directly I can jump to the address. So if I want to change the sequence of programming, I want to jump to the particular locations, then I use the branching instructions. So here they are given. The branching group of instructions allow the programmer to change the sequence of execution of program either conditionally or unconditionally. So here they are given some examples. JMP 4000. So this instruction is a jump and 16-bit address. So if I use this instruction in a program, the control will transfer to the 4000 location. So by using this instruction, I can transfer the control of my program, where we can say like microprocessor, to particular location. Likewise, the next is given jump on no 07000. So this instruction is applied whenever, for example, suppose I apply the JNZ 7000H after register C, after incrementing register C. So it checks whether it becomes 0 or not. So if jump on no 0 means if the register is not 0, then it will jump to the 7000. If it becomes a 0, then it will not jump. So JNZ. So it is a one type of conditions we are giving. So microprocessor will jump to the particular locations when that particular condition is satisfied. Otherwise, it will not. So JNC also same jump on no carry. So if the carry is not there, it will jump. Otherwise, if the carry is there, it will not jump. JZ here jump on 0. So if the particular register will become 0, then it will jump. Otherwise not. Here also, if the carry is there, it will jump to the given location. That is, here they are given 4500H. So this particular group of instructions are used to change the sequence of execution of program. And the last one is machine control group of instructions. Now machine group of control instructions are instructions such as a halt or interrupt. This type of instructions are come as a machine control instructions. So for example, NOP, halt, ring, sim, they are given. These all are machine control instructions. So in example they are given NOP. So NOP is nothing but no operations, that is no operation is performed. So this is actually 1 byte instruction, and this instruction is useful as time delay in timing. So specifically NOP is used to make the time delay. Then HLT they are given. HLT is a halt. If I want to halt a program, then I can use HLT. Basically this instruction is used at the end of the program. In N they are given. It is instruction is input port instruction. Out, that is output port instruction. So this in and out is a whenever I want to make a port programs. For example, this in instruction is the data placed on the 8-bit bidirectional data bus by the specified port is moved to register A. So this is in, and out is the content of register A is placed on the 8-bit bidirectional database for transmission to the specified port. So this in fourth is used whenever I want to transfer a data from the code to the register A, and out instruction is used whenever I want to transfer a data from register A to a database. And rim and sim, they are given. So rim is read interrupt mask and sim means set interrupt mask. So in upcoming videos I will tell you in detail each and every instructions working, as well as the number of bytes of instructions. So this video is all about categories or types of instructions in 8085. So in this video, total 5 group of instructions are there that we learn. That is data transfer group of instructions, arithmetic group of instructions, third one is the logical group of instructions, four is the branching group of instructions, and the last, that is fifth one, is machine control group of instructions. Thank you. Thank you for watching my video. If you like my video, please subscribe the video. Thank you once again.